hello. 21st of Christmas, or 21st of December, I'd say. And it's another puzzle day. Let's start here. Looks like there's a 2D grid of some sort. Two pages that have the 2D grid. Where's my pen? Pen has traveled. Hold on. Okay, here's my pen. Let's see what we have. Step counter. You manage to catch the airship right as it's dropping someone else off on their all expenses paid trip to Desert Island. Oh, I think we've been there. It even helpfully drops you off near the gardener and his massive farm. You got the sand flowing again, great work. Now we just need to wait until we have enough sand to fill the water for Snow Island. And we'll have enough snow again in no time. Oh wait, actually, yesterday we got the sand machines working, not the snow machines. I thought the machine network was for the snow machines, but no. They were for the sand machines. Okay. Filter the water. Such first world problems. Like just put in natural water. While you wait, one of the elves that works with the gardener heard how good you are at solving problems and would like your help. He needs to get his steps in for the day. Okay, so that's why we have a step counter. And so he'd like to know which garden plots he can reach with exactly his remaining 64 steps. Okay, so which garden plots he can reach remaining 64 steps. He gives you an up-to-date map, your puzzle input of his starting position as garden plots, period, and rocks hash. So S is here in the middle. For example, this. Okay. The elf starts at the starting position, which also counts as a garden plot. Then he can take one step north, south, east, or west, but only onto tiles that are garden plots. This would allow him to reach any of the tiles marked O. Okay. Then he takes a second step. Since at this point he could be at either tile marked O. So here. His second step would allow him to reach any garden plot that is one step north, south, east, or west of any tile that he could have reached after the first step. So here, okay. After 2 steps, he could be at any of the tiles marked O above. Yeah, that's right, okay. Including the starting position, either going by north and south or by west and east. A single third step leads to even more possibilities. He will continue like this until his steps for the day have been exhausted. After a total of 6 steps, he could reach any of the garden plots marked O. Yeah. In this example, if the elf's goal was to get exactly 6 more steps today, he could use them to reach any of the 16 garden plots. However, the elf actually needs to get 64 steps today, and the map he's handed you is much larger than the example map. Starting from the garden plot marked S on your map, how many garden plots could the elf reach in exactly 64 steps? Well, this looks like a fun question. Yeah. Okay, I'm actually thinking about this. There was this dominoes puzzle that I read maybe at the beginning of the year or something. That was like a parity problem. Like how many dominoes can you put in, and you had to prove that there was no way to fill the dominoes, and it was like a parity problem. But here, this one is also a parity problem, right? Because if you start, let's say here, if you start at S, and let's say that that's the 0, 0, then if you take just one step, you are either at plus minus 1, 0, or 0 plus minus 1. And if you take x plus y modulo 2, it's either 0 or 1. So basically, if you think like this is an even square, these are odd squares. So you start here, you're at an even square. Then you go to odd squares. Then you go back to even squares. And then you go to odd squares. And another thing that I'm thinking, so one, there's parity. And that means that okay, yeah, so there's parity in this problem. I don't know if that helps anything, but but there it is. And then the second one is that if I think what I can reach, like if I can what I reach at reach at 0 steps, which is S, that is strictly smaller than what I reach on second 2 steps. Or that includes, let's say includes, and that includes what I reach on 4th step, and likewise what I reach on 1st step is a subset of what I reach on 3rd step, which is a subset of what I reach on 5th step. I guess technically they should be like, because I might have walked the whole map, so I cannot go anywhere anymore. And then so forth. So this is like a tower of yeah, the boundary just grows, and we always have the previous ones that we were at. So that comes to mind. And then what comes to mind, actually, the Manhattan distance. If we take like x steps, if we take k steps at Manhattan distance, and no rocks, then the shape would always be a diamond, like this. S would be in the center, and then this diamond would just, like this Manhattan distance diamond would just grow. So actually, if there weren't these rocks, I could just like, I wouldn't have to do any kind of search, and I could just scan. And it would be like this kind of parity every second square inside this diamond. So I'd have this Manhattan diamond. So that's what I'm thinking. But because there are these rocks, so I cannot get, for example, here immediately, like outside this. Then I'm gonna do a bread first search. And as luck would have it, yesterday I did have a bread first search, so. Yeah. The question is just how big is our map, how well does it fit in memory, and how much work RAM do we have to work with. So let's save some inputs. I think the first one we're in a good spot to solve. Save 9 2023 dot example 21 txt. And then save the puzzle input 9 2023.input 21 txt. I just realized I can operate in place. Like when I calculate these steps, I can operate directly on my on my map. Like these periods, I can use this the memory in this period as free space, and then these hashes. Yeah. Yeah, that's gonna look cool. Let's do that. Okay, so for the couple of last days, going again for our mantra here, example 21 txt 9 read. And okay, max width 0, max height 0, while f gets rs is 200f. Oh. Plus height if not max width equals string length of s. Printf so that's that's the usual code. Let's see how that works. 12 by 11 for this example. Yeah, that's probably right. How about the input? How about the input? What size are you? Do you fit in 8 bits or 7 bits, or how many bits do we need? How many bits are you gonna fit? Ooh. Size is 132 by 131. Okay, so not not quite 7 bits. We do need 8 bits. Okay. U8 map 140 by 140. Let's go by that. Is that that's probably like 20 kilobytes again. That's what they usually use. Okay, and I'm going to read this again as, let's do width height as sentinel. So what I'm gonna do is char star s equals, let's do define stride 40 s equals m plus stride plus 1. Hold on, actually what I'm gonna do is do memset m 0ff yeah, my sentinel value is gonna be ff all bit set. And then u8. And let's just go with, yeah, u8. Now I need char star here. Plus height. You can go outside the loop. Width equals string length. We're probably not even gonna need the width. So plus height, s plus equals stride. Then actually I do need to do s equals, s is dot, then 0, otherwise 0xff. So I'm going to change that all the periods are zeros and all of the others are ff. Yeah, that looks about right. And then I'm gonna do actually I don't necessarily need the height even, but what I need is char star start equals oh, not here, no, not here. start equals stir. Oh no, actually I do need to have that in the inner loop because of no, still no. We're gonna do this. U16 index equals 0. Index is smaller than size of m plus index. If m I equals s, U16 start equals I, and then mi equals mi is a dot, then 0, otherwise ff. So now I can do the whole thing in one loop. Okay, and then we have our struct xy q. What's the Manhattan radius? 64 plus 64. Yeah, 256 is gonna be enough. And yeah, U8, Q begin, Q end. Okay. And then let's do the breadth first search. What are you here? You go here. Yeah. Okay. Q. Well, let's just use begin and end. Q begin plus or end plus equals U16 plus. Actually, why don't I just do this? Why is this a struct? U16. Yeah. Equals start. Q E plus equals start. Equals I. Okay, and then we search. So U16 steps 2 equals so I'm gonna have like two variables that are like the the oh actually why no I don't, just steps equals 0 or steps equals 1. Yeah, because map starting position let's mark that visited. Well, actually, it is getting marked visited in here. Yeah, so no, steps, not reach. Oh, that's because I need the parity. So that's why I was going. Yeah, now I realize. So I'm going for the reach. So initially at 0 steps we can reach 1 because we're at start, and then that's the odd reach. Yeah. Okay, so and then for U16 steps equals 0, steps is smaller than was it 4 steps in the example? After a total of 6 steps. Six steps. While U16Q end. So now I need to make a copy of my Q end. This is how far I'm gonna go in this iteration. While begin is not Q end. U16 pause. Actually, maybe I don't need to. 4 plus B. And now I need to do the bread first walk. So if not map position -1. How does this look? Plus reach 0. Now position is QB. Plus reach 0. And Q end plus equals, yeah, let's take the U16 pos equals QB. P -1. So this is this is going left. So equals P -1. Can I put this in one line? Oh, we're going, I guess we're going single line variables in this one. So I have this one. Left, right, up, down. left, right, up, down. Okay. And then at the end, swap reach 0, reach 1. And reach was of course a single variable. No swap. It was uppercase, okay. Printf reach after we'll just reach, I don't have that variable, equals R1. It's now swapped at the second step. Oh, but I don't. This is not a single liner after all, because I still have to mark M. Actually, can I mark? No, I do need to mark here, yeah. P minus 1. P minus 1 equals 1. Oh, so annoying. Here, I'll probably make this a macro or a separate function and hoist all of this stuff to be globals. Probably a function. MP minus S equals 1. So it goes like this, MP plus S equals 1. Okay. Okay, how does this now look? How does this now look? Size of M. We grab the start position, the queue first, and all the spots get either a 0 or FF. And then we do the parity thing. So this is exploiting the parity and this sub walk thing. Let's see what happens when I run this. Oh, I ran it on the actual input. I didn't mean to. I wanted to run on the example because it's not asking how far can you. Yeah. I only had 6 steps, so this number is not gonna mean anything. Oh. Yeah, I don't want to pause this because I know that this has been known to crash. Reach 40. Okay, so it didn't it didn't at least load on me. So let's see. Reach 15. No! You could reach 16, not 15. Did I miss something with this? Okay, I guess I need to visualize, so define stride equals 40 and U8 star M is why I guess it wouldn't strictly need to be volatile. And then here now I actually need to do 1000. And here 1000. Mem set 8 star. Yeah, it doesn't need to be volatile, but okay. Oh, this actually needs to be just tried. But yeah, now the issue is that these characters I use. Let's choose A here and 0. So this is going to be the @ character. Actually, yeah. And then I want to do equals. Let's go with B. Or these actually, no, because these are screen codes. This actually won't. Actually won't do it, but. Okay, what was that? Why do I get such weird okay, let's see, where's my manual? Let's look at the screen code. C64 screen code. Here. C64 screen codes. Screen codes 315. 315. So here's the screen code. So, oh, 1 is A. 1 is A. So I could have just used 1 here. Yeah. And then here I'll just use 2. Oh, it sketch. Don't eat my. Okay. AABB. Huh. Okay, this is not that easy to read after all. So, what do I have? Oh, I do need to distinguish the walls and such. I start at Okay, so these are rocks, and the spots that I've traveled. No, this is not that easy at all to figure out. So, how do I do this? Else. So the start position at a map can be, let me see. Screen code capital S is 19. Otherwise, if it's a dot, it can become, oh, but it must be 0. That's an awkward thing for me. What's the hash? 35. And these can become O's, 15. Why did it? Well, this is a little bit more readable. Actually, let me add a sketch here after every step, so I can see what happens. So we're at the start, and we've now done O's, so we're at the 2 spots. Yeah, that makes sense. Now we're at 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22. Now this is feeling just right. Oh, am I printing the wrong one? Am I actually printing the wrong one? No, 14 and 15. I want to do U8 char equals steps percent 2, then 15. Otherwise, let's go for, what character should I use? I will use 43. That's a plus sign. So then I'll have this one to dedicated character. So that's 2, 3, 2, 3, 2. So this is now the final answer. So how many pluses do I have? 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13. Wait, what? "13 pluses and 15 O's. Oh. Yeah, that's my problem. Okay, so that's my bug, I'm pretty sure. Reach 16. Okay, so I'm pretty sure that was my issue. But now to take this back, I need to undo a bit. Actually, let me save before I do anything else. Yeah, I was attributing... Yeah, I was attributing the start to the wrong parity. Okay, so size of M. Of M. Okay, these values can be like that, it doesn't matter. And well, this character thing doesn't matter either. Yeah, let's see what happens. Reach 16, okay. Okay, and what was the thing? Yeah, 64 steps on the big map. Let me just actually add this. Now I don't need to. That's just because that's just extra computation into the inner loop. Okay, let's give it a run. Oh, and again, I forgot. I should have added prints to get a status, but I don't think this should take long at all. After the thing. Yeah, after it loads up the file. Three, 4, 9, 8. 3, 4, 9, 8. Okay. Let's see what the judge says about that number. Answer 3 more. Oh, too low. It's too low. Too low. Oh my gosh, why would it be too low? Darn. Darn. Actually, now I need to... Yeah, all of this screen space stuff was maybe a distraction. because now I do need to visualize this whole thing, so actually I'm just gonna do a regular print. Let's do access or yeah, this is much more sensible. X or character. Could I be blowing up my queue? Let's actually check for that. I don't think that should be the case. Or this print could actually no. Well, no, it can't. It can't be like this. Okay. And then after this one, for x equals, what was the width? The width was 132, so that's 65 minus 20, so 45. X is more than 45 plus 39. Map y times stride plus x. Okay. Yeah, that's a simpler visualization. Okay. Ooh. What is happening? Oh, I can have this. Well, actually, yeah. What am I doing? What am I doing? So silly. Oh, because I'm hard coding the numbers and I was on the example. Yeah, let's try the actual input. Okay. Start O. Okay, that was silly. What was going on there? Okay, so this, but let me actually do so 130, 65, 55, 55 plus. And here I'm gonna do float set. Okay, let's see how this works. Cool, all right. So we get the O's, the X's, the O's, and it goes in that diamond shape. The X's, O's, X's. And it's working just beautifully. So why would I have a too low result? Yeah, it feels like the visualization is spot on. I just cannot see the whole map. And there, yeah, I could see that the top left corner got filled properly. And here as well, bottom right left went around the corner. So I feel like this code is all correct. But I must have some. Oh! Oh, okay, so I did blow up this queue of mine. Okay, so that's the issue. Ah, nice, okay, now I know how to fix this. Okay. That's surprising that happens. That's a little bit surprising. Because 64 steps, it's 4 times 60. So I thought that it would have to, by necessity, like you would, 4 times 64 is 256, so that this would always have to fit. But I guess no. So I was just using like 8-bit wrap around. So I could use like easy plus here. So now I need to move E equals E plus 1 and 26. Go away. Interesting. Okay, this could have been a first attempt, but I decided to skimp on memory. B equals B plus 1 and yes. And now there's absolutely no way, like, you cannot in 64 steps build 1,000 neighbors. Okay, let's see what our updated number is. Oh, did I leave a gedge at the very end? Did I leave a gedge at the very end? I didn't all comment. Well, I guess I'll see pretty soon. I'll see in a moment. $91. Oh no. Where am I screwing up still? What? This happens just once. What the heck? What the heck? Where am I screwing this up now? We can also go here. Like this. And Q and equals end. You can go away. I know that this is correct. Huh. How bizarre. Did I have... Let's try running again. Let's try running again. Just to double check. Three seven three seven. Oh, okay. So the previous one actually, yeah, that was a rather nasty bug in my synchronization, I bet. So it was actually running some other code from before. Okay, so now let's try with that answer. At least it's higher than before, so that's pretty good. 21. Answer 3737. Yes, okay, yeah. Okay, so why? I'm kind of surprised that it could blow up my 256 byte queue, because if you do 64 steps at a diamond shaped Manhattan distance, like that would be, yeah, I'm not quite sure why that happened, but in any case, let's see what kind of crazy stuff we get for the second part. So let's take it to the printer to get our description and give it a look. Okay, so that was a lot of printing, but that was because I actually messed up and made it print also the first part again. So, yeah, I should have selected just the description for the second part. So easy to forget. Okay, so we got a huge number of paper, but only actually the second part is the interesting one. So that's 2 pages. Let's see what happens. So part 2 starts here. The elf seems confused by your answer until he realizes his mistake. He was reading from a list of his favorite numbers that are both perfect squares and perfect cubes. Not his step counter. The actual number of steps he needs to get today is exactly 26.5 million. He also points out that the garden plots and rocks are set up so that the map repeats infinitely in every direction. So if you were to look one additional map width or map height out from the edge of the example map above, you would find that it keeps repeating. Oh, okay. This is just a tiny 3 map by 3 map slice of the inexplicably infinite farm layout. Garden plots and rocks repeat as far as you can see. The elf still starts on the one middle tile marked S, though every other repeated S is replaced with a normal garden plot. Period. Here are the number of reachable garden plots in this new infinite version of the example map for different numbers of steps. However, the step count the elf needs is much larger. Starting from the garden plot, march S on your infinite map. How many garden plots could the elf reach? Exactly 26.5 million steps. Wow. Wow, indeed. Hmm. So there is this diamond pattern that repeats. So there is this kind of thing that happens. I can kind of calculate like the area of this diamond. Like if there weren't these rocks, this would be like the radius here, like this length would be this 206 5365. So the diameter is 2 times that radius. So the diameter is 2 times this radius. So if I have this is 2r, then if I rotate this 45 degrees, I have this shape, where this is 2r. So this is 2r divided by square root of 2. So this width is roughly, so this is roughly this much. So this is roughly square root of 2r. That's, and the area is that squared. So 2r squared. So basically 2 times this squared. So roughly the step numbers he gets in are 2r squared minus, when I calculate the number of copies that this map repeats inside this area. So this thing repeats like this thing repeats here. So I could calculate how many full copies of this fit in this diamond, and then clip the thing here, but there is still the pathfind problem, like for example these squares, you know, they are not that easy to, like, you have to go very much around to reach them. Or this one. Or maybe this is the farthest thing. Yeah, so that's kind of could I on the PC, what I could also do to account for this pathfinding problem is to calculate this whole diamond and then think, like with some safe guard band area, think about all the copies that fully and safely fit inside this diamond like this. So I don't need to pathfind those. But then I would have this remaining kind of like iffy area of these things that do click. Maybe I would pathfind all those that actually intersect with the boundary. So I would be pathfinding to get to answer those specifically. And because this is a diamond, I always like can start this pathfind from like one of the corners of this. Like when let's say if I have this square that clips here, I always can start it from one of these corners. So I would be doing like these pathfinds would be going from this corner, then these ones would be doing from the opposite one. And that would be the solution. But yeah, I think this is definitely getting to the exploratory realm where I do need to explore this code and visualize, like be able to productively visualize this. So this is definitely the type of problem where which I'm not gonna be able to just get on the spot on the C64. So today I think this is gonna be another day where I first look to solve this on the PC and then port back. Then port the solution back to the C64 if I get a fast one that the C64 one can compute. I think that's what this is gonna be like. Now, before I think, actually, would there be this kind of loop? No, I don't think this is not like the Tetris boundary or the the others loop problem that we had before, where I could determine a cycle and then multiply fast track. The reason for that is that the boundary size always grows, so I cannot kind of like take like 1 by 1, 3 by 3, 5 by 5, 7 by 7. Because that's gonna like increasingly grow. So this was 130. The width was just like 130 or something like that. 131. So that means that there's like several, like dozens of thousands of copies, like tens of thousands of copies that fit here in the radius alone. Yeah, so I think that's definitely my approach, to basically just immediately. So these four edges are actually special, because those I want to start the pathfind here, and then pathfind that clipped thing, and then I want to walk the perimeter of this big diamond and solve these small pathfind problems where this thing clips. So I need basically like a generator function that computes this one, like this clipped things. But that's pretty easy, because I can take this radius divided by the width, or take the modules with the width. So that's how I know how much this is gonna go past here, start here. So I just have a function that solves this pathfind. And this is symmetric too, actually. So I only need to solve this. Oh no, it's an actual, not symmetric, because the starting point corners change. But yeah, I think this is gonna solve it. I'm confident this is gonna solve it. I can calculate these individual pathfind instances with different starting positions, walk the perimeter, then tally all of this up. The counts here are gonna be quite modest. Like they're gonna be, yeah, it's gonna be easy that way. And yeah, I'll take this approach, running on the PC. Then I calculate how many of these total full things fit in the map, and then sum all of it up, and then I see what the runtime is gonna be like. And see if this could ever run on the C64. Now actually, hold on, this is a 45-degree slope. This is a 45-degree slope. So could it actually be... What was the width? I marked down the width here. 131. So what is the modulus between this 131 and this one? Because I'm thinking like with some luck, or like could this problem have been made so that, because this is a 45-degree slope and the size of these individual maps is a square. So could they have made that? Because like if it goes like directly in the diagonal, then all of these things are gonna be solving just like this kind of shape. So I need to solve this just once and then it's gonna work. But even if it's not, if it goes like, let's say it goes like here, then I still have potentially this kind of like I can memorize the solution, like solve from this corner with this max distance, and then this is gonna repeat at some point because there's only so many starting positions you can have. So then I can enjoy the memorized solution. So I can cache these results. But maybe they were cheeky and this is actually a true multiple of this. Or they have common factors. I mean, at most I need to solve 134. So at most I need to solve 131 individual path finds because that's the maximum. No, by times 2. So the maximum path finds I need to solve is 262. That's the max possible step distance here. And then the thing is gonna repeat. So I don't need to calculate. So either it's gonna be, I bet this is a prime. This is probably a prime. So either they're cheeky and this divides cleanly and this is a diagonal like this, or I solve 262 of those per each edge. And that's all I need to solve. So basically, yeah, so the computational complexity for the C64 is going to be at most 4 times 2 times 131 path finds. So that's about 1,000 path finds. And one path find took maybe 10 seconds. So yeah, it could. The C64 definitely can calculate the solution, but I'm not gonna go and try to develop the solution for this in here. Rather, I'll take this to the PC and yeah, I think this enumeration this should definitely be workable. Okay, but yeah, so that's everything for this video. Finished in a good time, hour and 40 minutes for this one, so it's not gonna be a hugely long one either. And I'll write up in the blog on what I come up with. So, but now I think I'm gonna go and grab some lunch and then come back to take a crack on solving this. So take care, internet. I hope you have good today, and then I'll see you later tomorrow. Bye.